My name is Jay Nygaard. I'm president of Go Green Energy, and I'm here to talk to you about renewable energy options. I know mostly focused on wind, but I like to start the presentation off with a way to get your hands around how our energy picture looks in our country. Okay, topics today will be energy production, solar power, energy storage, mostly wind turbine, and potential product lines. And I kind of made this not just for the Port Authority, but for the schools down here and for other people we're seeing. So kind of a general deal. Who I am, I was Navy nuclear power machinist mate back in the 1980s. I got my mechanical engineering degree from the University of Minnesota. I attended in the solar power school. There we go. I'm a class gauge 1 energy gauge rater in Florida, which is hard to do too. Not sure what's going on. I'm president of Go Green Energy, but if you flip over the business cards I gave you, what I'm almost most proud of is I've been named the U.S. Technical Representative for Hybot Technology, the wind turbine manufacturer. And that's something I had to earn. These people at Hybot are extremely smart business as well as technical wise, and I really had to earn that title. Don't get paid for it, but it still means something to me. How we produce energy. 35% natural gas, 17 coal, 19 nuclear, 18 renewable, and 1 oil. This has changed since when I first started doing these presentations 4 or 5 years ago. Coal used to be the top. Now coal's down. Renewables used to be about 10%. Now they're up to 18%. And what we're going to find out, the biggest jump, which by the way is kind of how we want to go because we're reducing pollutions as we do this. Hydropower is standard at 7%. That really hasn't changed. But wind power used to be 1%. Now it's up to 6.6. Solar power has gone up a little bit, and biomass used to not even be on the list, but here it is now. Baby, where are you? There we go. I always say this first because this is the cheapest, best way to save money. The building envelope, your lighting, and using modern technologies. You can spend 2 to 3 times as much money on renewables if you don't do these right. So this is always the first most important step. Traditional, solar thermal, photovoltaic, and big wind, but the emerging are small wind, micro hydro, and geothermal. And geothermal has always kind of been there, but it's just so low on our list that I like to keep it on that part of the list. Solar thermal, I'm going to talk about that probably first. It's the best renewable energy investment. It's the best return. Hawaii has now required all new building to have solar hot water in it. I have a solar hot water on my vacation home in Florida. We almost never have to turn the hot water heater on, only if we have a lot of guests or whatever. So free hot water is the best thing you can do. It's the most expensive thing to heat up. So even the Port Authority, thinking about you guys, I mean, I'm sure you got hot water taps in the bathroom or whatever. This is something you definitely need to consider. And I actually know a manufacturer of solar hot water systems down in Florida that would work perfectly here. Photovoltaic power, I'm a definitions guy. That was drilled into me early, so I just like to explain. A module, these are all individual modules. A panel would be one row. The array is the whole thing. So here you got a couple arrays. We all kind of know how geothermal works. You got natural. I mean, I don't know if people know, but Iceland is mostly powered by geothermal. That's just what they have. Or you can make them with drain fields and all that. And actually, geothermal's come a long way. Up in Minnesota, we can heat a house with 40-degree water coming out of the ground. You wouldn't think so, but a 1 to 2 degree drop in that temperature in the water is all you need to heat the house. Small wind is definition-wise 100 kilowatts or less. You have horizontal and vertical, but micro wind is kind of a new thing and a new term, and the definition varies anywhere from 1 to 5 or 10 kilowatts or less, but it's definitely smaller than the big. Micro wind is typically battery charging, or it can be grid tied. This is a vertical or horizontal axis, meaning it spins around the horizontal. That's what the big propellers are. These are called vertical axis because they spin around the pole coming up. Problem with horizontal, the noise, vibration, reflections, and they've got a lot of moving parts typically and a lot of failure mechanisms. Blade could break, a bearing could go. It might not be able to find the wind. You know, there's all kinds of reasons. Plus, these typically have a little higher startup speed to get going than our vertical. Now, the advantages of vertical axis are low vibration, little noise, lower RPM, and they can catch wind, you know, turbulent wind. To me, they're truly urban and suburban compatible. You know, yeah, big propellers make a lot of noise. People aren't going to like those 80 feet in the air. You can put these 20, 30 feet in the air and they can be successful in the right places, just like having a big flagpole. Okay, my company kind of mostly into now solar power, energy storage, and wind turbines. I do a little other, you know, speaking engagements and stuff, but this is the focus. And I think you're going to be pretty impressed when we get to the batteries. This is a system I put on a house in Minnesota, and this is a new modern house. I actually learned a lesson off of this one. Because everything in there is so technical and modern, and being a certain size build, the power company would only let us put a certain size solar system on. Well, it turned out he's only making half the electricity he needed. So he's got a green roof here and here, and we covered those green roofs with solar too, so he can do it. But, you know, I would say a typical house uses 35 kilowatt hours a day in electricity. Well, when you get a modern house with all the new features, you're going to double that. Another small system I put on a house, they're quite happy. This is a system I put on a business, a metal manufacturing shop. They had a bill of $250 a month that I basically got rid of. This is another bigger home. There's another system on the other side. Interesting thing about this is the roof was nowhere near level, but we were able to get the solar system to look good. And he's got a geothermal system himself, which is why he needed such a big system. So he's just about going to be self-powered and self-heated. One thing I like to do is I like to use N-phase microinverters where you put one on the back of each module. So each module is its own little electrical system. So if one gets shaded over here, it doesn't affect over there, which is a big problem with solar arrays. Plus with the N-phase system, you've got online monitoring so you can see exactly how your system's working or worked, or you've got all kinds of numbers. This will be important for you when you put your solar on, especially at the port authorities. You're going to want a big screen down there that everybody can see. This is what our solar is, this is what it's doing, this is what it's done, this is what the wind is doing. You're going to want to advertise this, and this is how you do it. You can do it with the wind as well. Something else to think about, I don't know if you have covered parking or not, or if you want to offer it, it's a great place for solar too. The biggest reason is, see all this air underneath and all the air above it? It's got nothing under it to hold the heat, right? It's got a lot of airflow. Solar does not work good when it gets hot. It works great when it's cold. Up my house in Minnesota, on the roof, I live on a lake. On a sunny day with the sun bouncing across the snow, my modules could be putting out 120, 130% capacity. Down here when it gets really hot, it could put out 30%. Now there's newer modules that are designed better. There's actually one in Texas called Mission Solar, and their big object is to design high heat environment solar modules. So there's a lot of options for you, but I just want to show you if you're going to do carports, there's a few different options, a few different things people have done just to kind of spur your thinking. Energy storage, batteries, basically. Conventional lead acid, that's what we all have in our car. In about 5 years, we're all going to have AGMs in our car because those are going away. These are hazardous waste. These are not. These can break open. You have a hazmat situation. These, they don't. There's nothing to spill out of them. So this is a wave of the future. You also have a lithium-ion, which is a Tesla style, or lithium iron phosphate. These both have their advantages where they're going to be used. The disadvantage with the Tesla is it can start on fire, where these aren't going to. I mean, that's especially if it's in a car, that's not a good thing. But, like I like to say, gas starts on fire too. And then the lithium iron phosphate, and I'll show you the big bonus to that in a minute. Here's an absorbent glass mat, that's an AGM. What they do is they put a mat and a plate and a mat and a plate, and they kind of squeeze it all together. So they take something this big and they make a battery that big and compress it so everything's integrated and contacted. So you don't need any fluid in there. That's why there's no hazardous waste. These batteries perform about twice as good as an average lead acid. Where they say in a solar system a gel or a lead acid might last 8 to 10 years, these really will. As I said, spill proof, up to 5 times faster charge, vibration resistance. I put these in my old Chris Craft boat and they're working great compared to what I used to have to use. They cost more, of course. You don't want to overcharge them. Just like all batteries, they got to be stored in a charged condition or else. Where are you now? There you are. Now we get to the lithium-ion. This is Tesla. It's basically an ion transfer, one way or another, how it's going. And it's just something that's, same kind of thing. They wrap 1, 2, 3, 4. When you see a lithium battery that looks like a car battery, it's not really a car battery. It's got a lot of these little things wrapped together and all soldered together. Lithium-ion battery market share, just give you an idea. Telephones, cell phones, whatever. Car batteries, that'd be more the Tesla and the hybrids. Grid storage, that's something I'm going to talk about in a minute, and something you might want to think about too, and then just other uses, whatever they may be. Now here's a big bonus. So here's your Tesla battery, and here's how it degrades over life. Here's how the lithium iron phosphate, they can hold their ability much longer. They decrease at the end, but you're already so far past the Tesla ability. It's just a better long-term battery. The Teslas are more likely better in the automotive situation where they have a higher demand and a higher current draw. These would be better in a battery storage, solar power, or sun and communities. I'll explain what those are in a minute. I'm a certified sun representative, installer and transporter. I've gone through the training and passed all their testing to do that. They're the ones I represent. They're lithium iron phosphate. Now, what they have done in these sun and communities, they'll put together a community, and they did this in Arizona where they've got 3,000 homes. Each home has a small solar system and one of the batteries in it. And it's really interesting because up the street they've got a nuclear power plant that every night they have to pump energy into the ground because they got to keep the thing running. They also happen to have what they call idler plants. And they have all these around the country where maybe 4, 5, 6 times a year you need to fire it up because the use is so high. But you have to have them there and ready all year long, and that costs a lot of money to keep them ready to go. Well, what they did with these 3,000 homes is they produce enough solar power to run the house during the day, but at night they basically run out the batteries, and the power company can draw off of these 3,000 batteries for the rest of the community, and they were able to shut that idler power plant down because they've got the energy reserve in these batteries. And what do they do at night? Instead of pumping all that power into the ground, they charge these batteries from the nuclear power plant. So they kind of figured out how to make a system work better, but here's the bonus. The guy who owns the sun and community and designed and developed it, he's getting over $1.5 million a year from the power company for this to happen. So if you put a bunch of these batteries out there as part of your system to keep yourself up and running when the power goes down, Sun has what they call their utilities team. They'll go approach a utility and say, we have an offer for you. And they'll help negotiate a situation like that where you guys could potentially make money by having these in your building. Now on to the best part. Micro wind, vertical axis wind turbines. Brought up a quick wind map to show the best wind in the country is pretty much right in here. And this is a big part of why Texas is so big into wind power, so good. It's not really the best, but once you get back along the coast, it's better. So Texas, the majority, you're not so good here, but the majority of Texas is a good wind area. So that doesn't mean wind's going to work everywhere, okay? But it does have the potential to work where you have opportunities for it to work. And as you were saying, Texas is the U.S. leader in wind production now. Nobody, I mean, California's kind of close. Nobody's really close. Look at that. 21,000, 7,000. I mean, Iowa's got more than California. And wind jobs. A lot of wind jobs, and Texas is right in there for that too. And that's what we're talking about, potentially providing jobs, putting all this together. Okay, these wind turbines, they have an inner Savonius blade and outer Darius blade. What happens is, in low wind speeds, the inner blades catch the wind and get it spinning. Probably won't be making much electricity off these inner blades. Around 10 to 12 miles an hour, the outer blades pick up and produce most of the power. The reason they did that is, especially in vertical axis turbines that spin like this, they have a hard time getting started. They have a hard time getting going, and sometimes it takes a big gust of wind. Well, putting these blades in the middle solves that. They're mostly aircraft aluminum, steel or stainless steel structure, and depending on the model, the only moving parts are 2 or 3 sealed bearings that are sealed in there. So there's really no failure mechanism. There's no alternators, there's none of that. The generator's right on the bottom here, and it's magnet spinning around a winding. Very simple. Okay, as I said before, low vibration, low noise, durable construction. These come with a 5-year guarantee, which is unheard of in the industry, and they have a 20-year expected life. Like I said, I've been installing them for 8 years now, and I haven't had a mechanical failure yet. Okay, our 3,000 watt model has been certified by the Small Wind Certification Council. It is the first and only vertical axis to ever be certified. There's 12 or 15 propeller styles, 1 or 2 small ones that are, but this is the first one that's ever been certified. The big thing to note, 42 decibels. They really don't make a lot of sound. You aren't really going to hear them over the wind, unless, you know, you got a lot of them in one area or something, but they really don't have that problem. Here's a testimonial from a client I had, and what this work too is Lightspeed Internet. He was a cell service type deal, and he had towers all over. And on one tower, he had to have several. He tried several different propeller style turbines that all failed, causing damage or whatever. He put our turbine up, and it worked so well. He's able to remove the backup generator from the system. So it was a tremendous job for him. Of course, that is a place where you have opportunity to succeed. Top of a tower in a windy area. Different sizes, 300, 700, and 1,500, 3,000. This is typical. The 700 can be grid tied, and these two can charge battery banks too. I've got a 1,500 in the high Rockies of Montana. I'll show you in a few minutes. That's part of an off-grid backup system or off-grid system. So to show you how they hook up. Turbine will run through some electronics and control cabinet, inverter, backfeed your panel, and you're hooked to the grid. It hooks up just real similar to solar. And the nice thing is you can hook up to single phase, 3-phase, whatever you need to. The inverters are flexible. Or you can grid charge. That could just go right into a battery. Now here's some international installations. This is a road that is completely around a certain fish farm, I believe. And they've got it circled with the hybrid light poles. This is a off-grid cell tower. Now this is an idea they came up with where we can stack these 3, 4, or 5 tall and have a bunch of them by each other to make a like wall of a wind farm kind of deal. That's at my house. I like that one. Little flagpole. This is in Roseville, Minnesota. This one's in St. Paul, Minnesota. On this one, we had to do 2 different things because they didn't allow turbines. We had to go through a conditional use permit. We had to prove no bird kills in 2 years. And we had to have no complaints from the neighbors over noise. And we passed both of those, no problem. And that's a nice thing. There are no bird kills with these. The big turbines, how they kill birds, they got these huge blades going like this. And the tip of this blade could be 200-300 miles an hour as it's swinging around. And the birds, as they're flying, are looking down. Right? And the blade comes down and crunches on them. So they don't even see it coming. Well, with these, they can see the whole thing, and they can see if it's spinning or not, so we never have that issue. Right, this one's at New London Spicer High School out in western Minnesota. They actually built a greenhouse that they made a little geothermal to heat it, and they grow food. The kids grow food in there for the cafeteria, but they wanted to put the turbine up to offset the power for the geothermal. This is the one in the High Rockies. It's on a 40-foot pole with that little extension there. That's a backup. That thing was kind of hairy getting up. It was fun. This is my big idea. Put these things on top of ski lift poles up in the mountain. Where else would you? That's where the wind is, and someday, hopefully, I'll get to that. Now we get to the hybrid light poles. You can either have standard or you can have fancy ones. On these, they have them light up inside, changing colors all night long. Just a little LED string. And then they'll have two little 1-watt LEDs shining up so you can see the turbine at night spinning. Here's one of them I've got at the Minnesota State Fairgrounds. It's been there 5 years now. It's outside their eco building. This one's at the Shakopee, Midwauken, and Sioux organic recycling facility outside Minneapolis. And if you can see, there's a building back there. They didn't want to bury power from there to here. So instead, they just put this thing in, and they don't have to bury the power. Is at a gas station. A friend of mine, he needed a light pole, so we threw it right up there, and boom, it works just fine. No electricity. Off grid. This is over in Taiwan. This is a park. They kind of have a whole string of them. Give you an idea what they look like. South Carolina Research Institute. They've got a bunch of them in a circle there too. I actually got a video I can show you in a minute. This is that circle all lit up. More of it. Now, to give you an idea, you can brand them. So it says Volvo. You can make different designs, or you got a little palm tree in there. You know, you can customize these things the way you want to. Now, while this one's hybrid, that one is just solar. Parking lot of just solar light poles. Okay, potential product lines. Imagine if you had some hybrid vehicle charging stations there for your people to plug into. You know, when they show up, they know their electric car will be charged when they get back, and off they go. Hybrid parking lot lights, just like this. That would look nice for you. Backup system for schools, fire stations, prisons, whatever. You guys just recently rebuilt this number 4 fire station out here. Just wondering why there ain't a turbine on top of that flagpole. You need turbine, put some solar on batteries. You don't need diesel to back up the fire station when the power's out. It just runs itself indefinitely. And then, you know, farms, pumping water, or maybe even out on oil rigs. You know, you could put these things. Okay, more product lines. Exhaust vents up on top of the building. You design them so when the AC's on and it's pushing air through, these don't provide a lot of resistance, so it's really not going to affect your HVAC system. But you're going to be able to put some of the power you're dumping out back in. And the way I like to get people to understand this is we all know electric cars have electric brakes. And when you hit the electric brakes, it recharges the batteries a little bit as you're slowing down. That's kind of what this would be. You'd be capturing some of that energy you're using. You're never going to capture all the energy. You know, the way engineering works, thermodynamics, a closed system's a closed system. If you have losses somewhere, you have losses. But you can still capture some of it right back and pump it right back into the grid. Billboards, ski lift poles, I got that on both. For the 3000 small wind turbine farms, I'll show you a video about one of those. Or you can supplement large wind turbine farms too. Potential clients, schools, fire stations, prisons, hospitals, airports, assisted living. All these need emergency generators, emergency backup. What I'd like to do is design a system, retrofit for fire stations or any of these places or between solar and wind and batteries that they could retrofit that in and not have to count on a generator all the time. Because at some point you're going to run out of gas. Here's the exhaust vent idea. Comes right out the side or goes up the top. They're my ski lift poles. I keep saying those. Billboards, this actually was done in Texas, believe it or not. It's a friend of mine who owns Vertigy. And then in Oklahoma, they can't run electricity down to the dock, so I went down and put a wind turbine and solar and batteries in there to power his dock. So, you know, there's all kinds of opportunities to use these things. Now here's a Wangong wind farm. You can see it before it was flooded, and then after, and how big it is, and they put it in a wind farm type area. But the bonus to this is actually a fish farm. It was a fish farm to start out. So they went to put the turbines in, so now they make electricity and fish. And the big wind turbine farms, it's been proven that the wind flow at the bottom of these is about twice what the wind flow would be if the turbine wasn't there, the big one. So that's a perfect place to populate a bunch of these small ones down around where you're artificially making extra wind. Now, if you do want information, especially about Texas, you've got 142 policies and incentives for renewable. There's a place called Desire, D-E-S-I-R-E, USA.org. And they've got it for the whole country and federal, at least a mostly compiled list of incentives and grants and things like that. Well, that's one. And like I said, there's a list of them for Texas. Rebate programs, grants, policies, all that. And my little buddy Foo Dog says, go green or go home. That's on that green roof I told you about. Well, there you have it. I mean, that's pretty much the deal. I hope to kind of give you a round idea of what's going on. What kind of questions you have?
So the 300 size, is that the size that would be put on light poles, things of that nature?
The 300 or the 700.
Or the 700?
It depends on how many lights you're going to run off the pole, how much power you need to produce. You know, you might have a pole here that you're running 4 lights, so then we're going to need a little extra solar and the bigger turbine to do it. But the 300's about this tall, and the 700's about this tall.
And how expensive is it to maintain it?
That's a very interesting question, because if I give you the real answer, the people in the wind industry get mad at me.
Okay, but you have to give the care.
I haven't had to maintain any of them.
Okay.
Any of the ones I've installed are just still up and running. The one at the high school out in New London, Spicer, that did have an issue, but lightning struck it. And it burnt out the inverter and a few other things. The inverter was replaced under warranty, so it really didn't cost anything. And off we went. But that would be your biggest. It didn't. The lightning strike did not hurt the turbine. I checked it afterwards. I've got a way to check it and see, and the turbine was just fine. It just burned out the electronics.
These been installed in many places with hurricane force winds?
The engineer who is currently certifying my 1500 watt unit for Southwest Florida by Fort Myers in a 170 mile an hour wind zone recently certified the 300 for Dade County for Miami. And they've got as high a wind zone as anybody else. So, and you know, these are made in Taiwan. Taiwan's the typhoon capital of the world. Not only that, it's got a salty air environment, and that's exactly what you have here. Now, what's nice about these is they're all automatic. The big ones actually have a manual brake. You can go pull and shut them down, or you can go in the control cabinet and flip a switch and shut them down. They automatically shut down if the grid goes down. It's such a manner with 3-phase generators like this, when you cross all the phases all together, it's going to short circuit itself and it's going to stop. It acts as electronically as its own brake. They might spin a little bit, but the faster they spin, the more they don't want to. So it's a self-regulating kind of thing. And how the turbine electronics work is when the grid comes on, it energizes and pulls these contacts out. Well, if the power goes out, these contacts shut, short circuit everything, and it shuts down. Same with the 300s are a little different, but I've had that happen on my house. There was one time on my house, my turbine was going like a bat out of hell. And I'm like, cool. And I went downstairs, what am I making? And it was doing 300, 250, 350, 300, back and forth. And all of a sudden, right in front of me, it shot to 450, 550, 600, and it shut down. So it got up to 600 before the electronics could kick in, but it automatically shut itself right down.
Okay. fail-safes?